Hey Matthews, we're going to try to make this as quick of a video as we can. This will certainly be our shortest section of the chapter, and it's our last. So let's wrap things up and do it well. So let's get going. 6.7, extra practice. Determine the type of function represented by the table. Explain your reasoning. So what we want to do is we want to look at this table and figure out, first of all, whether it's exponential or not. So if you can multiply these numbers by something to get the next number each time, it's exponential. And if you can add them to get to the next number, then it's polynomial, which we've been doing for most of the year. So let's take a look here, and let's see if it's exponential. So let's take the second number and divide it by the first number. So 47, oops, quit. So 47 divided by 34. All right, we get 1.38. Now, if we take 62 minus 47 divided by 47, do we get the same thing? We don't. So these are not exponential. This is not an exponential function here. So what I'm going to do instead is I'm going to start seeing how far apart these numbers are. So 47 minus 34 is 13. 62 minus 47 is, what is that, 15? These are 17 apart. These are 19 apart. And these two numbers are 21 apart. Okay, so they are not going up by the same amount each time. But what if we do it a second time? These numbers are 2 apart, and 2 apart, and 2 apart. So now the second difference is going up by 2 each time. So this is a polynomial function, and since it happened on the second try, that would be a degree 2 polynomial. So what I know is if I was to graph this thing is quadratic. It's a degree 2 polynomial. Quadratic. Okay, what type of function? It's a quadratic. Okay, second one. So let's see. First of all, are the x values going up by the same amount each time? They're going up by 2, 2, 2, 2, 2. Okay, good. So now we can focus on the y's. Are they adding or multiplying each time? So here they're adding 2/5. Then they're adding 6/5. Then they're adding, okay, so they're not adding by the same amount. You know what I'm noticing? 3 is 3 times as much as 1. So this is 3 times bigger than that. 3 times. 9 is 3 times bigger than 3. So it got multiplied by 3. 27 is 3 times as much as 9 times by 3 times by 3. It's 3 times bigger each time. So this right here is a exponential function. Because to get the y values, you're not adding a certain amount each time. You're multiplying every time you multiply, this fraction by 3, you get to the next one. So that one's exponential. All right, so second exercise. Write an exponential function, y equals ab to the x, whose graph passes through the given points. Okay, so all we're being told is that there are 2 points, and those points are like, let's see here. 112, so that might be like right here, and then 3, 108, that'd be like right here. And they're telling us that these are points on an exponential function, but we don't know what the equation of it is. And so they're saying, if I give you these 2 points, can you figure out what type of exponential function would go through those points? So that is our job. There's 4 of them here, but if you know how to do one of them, you know how to do all of them. So we're going to do a really good job on number 3. And then if you don't quite get it after we do number 3, you could just backtrack and watch it again. So let's get started. Here is how we do this. So this is an x value and this is a y value, right? So what we're going to do is, since this is the simplest number, I'm going to do that one first. And I'm going to put this in as an x value. This is a y value. So y is going to be, so 12 is going to go right there. So 12 equals ab to the x. X is 1. All right, so let's just start out by saying, if I knew what the A value is and the B value is, I'd be done with this problem right now. So just so you know, that's what our goal. If we want to know the equation, we have to know what these two numbers are. That's why we're doing all this work. So can we agree that if we have B to the first power, you don't really need to have the 1 there? So I am going to figure out, I'm going to solve for A right now. So I'm going to divide each side by B. And I'm going to get A equals 12 over B. Why is that helpful? You'll see in a moment. So now what we're going to do is we are going to do what we just did, except instead of doing it for this point, we're going to do it for this point. So our y value is going to be 108 equals, and now instead of writing an A, we just learned that our A value is 12 over B. So instead of writing an A right here, I'm going to put a 12 over B right here. And you'll see in a bit that that comes in handy. Now we have to times that by B. And then that's going to be to the xth power. X is 3. All right, so now here is what we've got. So do you see how we've got a B to the third here, and then it's being divided by a B? So there's like a B to the third on the top of the fraction, and then there's a B on the bottom. So another way of writing this would be 108 equals 12B to the third divided by B. When you write it like that, do you see how this B cancels out with one of these, and we're just going to have like 12B squared here? So we have 108 equals 12B squared. Now what I'm going to do is I'm going to divide by 12, and hopefully you're picking up on the fact that we're solving for B right now. B squared equals 108 divided by 12 is 9. And take the square root of each side. B equals the square root of 9, which is plus or minus 3. So at this point, we have to figure out, is it 3 or is it negative 3? So here's kind of how I look at that. Remember, whenever we have exponential equations, the A is your starting value, right? And then your B value is whether it's growing or decaying. So let's think about that real quick. If your B value is your growth or decay, let's say you started out with like $1,000 to invest. I'm just totally making up something right now. And then it was going to grow by 10%. It would be like 1.1 here, right, to the x. And so because this number is bigger than 1, it's going to be growth. And then anytime this number was like, let's say it was going to be shrinking each time, anytime this number was between 0 and 1, if the number is between 0 and 1, then it's decay. So when I look at my B value here is plus or minus 3. If you had a B value of 3, that would mean it's growing, it's tripling every time. If you had a B value of negative 3, that doesn't even make sense, because if the number is bigger than 1, it's growth, and if the number is between 0 and 1, it's decay. There is nothing for if it's negative, like this value is never negative there. So it's not negative 3. B is just 3. Okay, so let's get back to our problem that we're actually doing here. And now what I'm going to do is I'm going to go back up to the original. So when I had that 12 equals AB to the first power, except now I know my B value is 3. So now I'm going to write 12 equals A. Since B is 3, I can go 3 to the, to the first power. So now I've got, well, that's going to be easy to solve. 12 equals 3A divided by 3. A equals 4. We said a few minutes ago, once we know what our A value is and our B value is, we're done with the problem. And we now know that A is 4 and B is 3. So our final answer is Y equals 4 is our A value, 3 is our B value to the X. So the whole point of this problem was to figure out what would be an exponential equation that would go through those points. If you were to graph this, in your graphing calculator, you would see that it does go through the point 112 and 308. So we just did problem number 3. 4, 5, and 6 work the exact same way. So we're good on that. Let's move on to the second page. We're going to finish with problem number 7. And for problem number 7, we're going to skip part B, so you can just go like that. We're going to do A, C, and D. So now we've got an Olympic swimmer starts selling a new type of goggles. The table shows the number Y of goggles sold during a 12-month period. So we've got this data here, and they want a scatter plot of it. So we're going to make that. So let's practice that. So get your graphing calculator and turn your graphing calculator on, and let's do this together. So here we go. We want to do the scatter plot. We've done this a bunch of times before, but we haven't done it in a little while. So remember, we go to the stats button, and then we go to edit, and then that lets us put in our x values and our y values. So we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right, so I just put some stuff in there. Just a reminder, if you have stuff in here that you don't want in there, you can go up there, clear, and enter. So if you're like, gosh, how do I get that off? That's how you get that off. So now I'll do it right. 1, 2, 3, 4, 5, 6. Okay, very good. Now for list 2, we'll enter in the y values, 28, 47, 64, 79, 97, and 107. Look at us go. Okay, so we've done that, and now we want the scatter plot. So I will go to zoom 9 for a scatter plot, and there it is. Look at that. And now I can, well, graph it. So 1, 2, 3, 4, 5, 6. Let's see, it looks like I'll go up by 10s, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so we've got 1, 28. 2 is 47. 3 is 64. Look at me go. 4 is 79. Good. 5 is, oh my gosh, my pen just broke. Shoot. Okay, I guess literally, it just broke in half. Okay, all right, we're doing this with a pencil now. 5 is 97, and 6 is 107. All right, we had a little technical difficulty, but we've got our scatter plot. Now it says to use a graphing calculator for part C to write an exponential model for the data. So now we're going to go to stats. We're going to go to calculate. And remember, we would do like linear regression, quadratic regression. We were doing that a couple months ago. So now we want exponential regression. So we're going to have to go down a ways. There it is. Number 10, exponential regression. And I'll hit enter again. All right, so there's all my exponential regression stuff. So write out the model. Okay, so y equals. All right, so my a value is 25 point a bunch of stuff. I'll go to 3 decimals, 25.815. Parentheses, my b value is 1.296 to the x. So now I've got my exponential model, and now I want to use that model to predict the number of goggles sold after 1 year. So this is going by 1 month at a time, so we want to make a prediction after the 12th month. So I'm going to say after 12 months, just so we don't get confused. Okay, very good. So how am I going to do that with my graphing calculator? So another thing that we did a few months ago, we just haven't done it in a while, is if you go to y equals, we can, remember, import that equation in here. Let's see. By the way, I've turned my plot on right now because I'm doing some statistical, analysis. So anyways, let's do, oh yeah, how do you do that? So to get this imported, remember you go to the vars, and then you go down to stats. And we want to get that regression equation there. So I've just imported that. So now if I go to zoom And I want to zoom in on the stats. So if I go to zoom stat, so that'll be 9. Now I not only have all the points on there, but I also have the line on there. And that's because I did that vars thing a moment ago. Okay, so we want to use this here to predict the output after 12 months. This window only goes to 1, 2, 3, 4, 5, 6 months. And so if we want it to go to 12 months, we need to make sure our window goes at least that far. So our X max is only going to like 6.5 months. So I'm going to make that go to like 15 months so I can see the whole thing. And I'm going to go back here, check that out again. Okay, so again, this is not new. We just haven't done it a while. So if we want to predict the output at 12 months, we can go second calculate, and we can calculate a value. And the value we want to predict is what is the output at 12 months. So I'll put a 12 there, and then I'll hit enter. And it's 582.097, which rounds to 0.98. Okay, predict the number of goggles sold after a year. How about we just round to the nearest goggle? We predict that they will sell 582 goggles. Okay, so that's great. We just practiced how to know whether something is polynomial or exponential just by looking at the table. We learned how to make an equation, an exponential equation, if all we have are 2 random points. And we learned how to use our graphing calculator to make predictions with exponentials the same way that we did with polynomials a couple months ago. So that gives us quite a bit of extra power. So at this point, you can stop the video and you can head to Big Ideas and you can work on your 6.7 homework. Thanks for watching. Good luck.